Okay, so in today's session, we'll start with TCP, Transport Control Protocol, or Transfer Control Protocol. There are two uh, def full forms to it. Some people call it transport because it's of a transport layer in the OSI layer model, and some people call it Transfer Control Protocol because it helps in transferring data from one place to another. Right? So TCP, Transport Control Protocol. Now, before we jump into the discussion of TCP, let's try to understand why do we first of all need TCP as such. Okay, so imagine we have a lot of layers in the TCP, not TCP, OSI layer model. So we have layer 7, layer 6, layer 5. Let's imagine there is no layer 4 as of now. Okay, you have layer 3, layer 2, and layer 1. Okay, and this is PC number 1. Okay, and this is PC number 2. Even PC number 2 has all these layer 7, layer 6, layer 5. There is no layer 4 as of now. Okay, layer 3, layer 2, and layer 1. All right, so now let's say that from PC number 1. Okay, from on PC number 1, let's say that the PC number 1 sent a message saying, "Hi, how are you?" Right, this is the message that it sent. Now consider each of these words as single messages, right? So at layer 1, obviously we have the physical layer, right? And layer 2 we have data link layer, layer 3 we have the IP addresses. So now what happens is that for each and every word, okay, this is word number 1, 2, 3, and this is 4. So for each and every word, an IP packet is created, right? So IP packet number 1, IP packet number 2, IP packet number 3, and IP packet number 4. These packets are created. These packets are individually wrapped in their respective frames, frame number 1, frame number 2, frame number 3, frame number 4. And then in the layer 1 wire, it is sent across to the other PC. Now, we know that when it is being sent from PC number 1 to PC number 2, obviously it is going through different devices, right? It goes to a switch, then it goes to a router, then multiple routers, then it goes to the switch, and then it goes finally to the PC. Okay, this is how it is traveled. Now, for some reason, let's imagine that for some reason, out of these 4 packets or frames, one of the frame gets dropped. Okay, one of the frames get dropped. Let's say that frame number 2 gets dropped here, right? So what happens is that the message that is received by PC number 2 is basically, "Hi, right? Are you?" question mark. So this sentence is basically not making any sense. "Hi, are you?" Like, is it asking, "Are you?" Asking, is there a further more sentence to it? Further more words to it? Are you working? Are you running? Like, are you drinking or are you eating food? Are you coming? Are you not coming? Something, right? Then, "Hi, are you?" Like, is like, "Hi, are you?" It does not also make any sense, right? So PC2 needs to tell PC number 1 that this message that you have sent me does not make any sense or is incomplete. Okay, it does not make any sense or is incomplete. How is that PC1 going to tell to PC number 2? So as network engineers, when we read this message, we know that this is incomplete. There is some problem with this message, right? So we try to work on it. Now what happens is that as network engineers, we would mostly work at layer 1, layer 2, and layer 3. Then when we check at layer 1, the physical cabling is good. Layer 2 frames are good. There's no problem with layer 2. In layer 3, it's also good. IP addressing, IP schema, everything, the protocol is running absolutely fine. There's no problem, right? Then developers who are working at layer 5, 6, and 7, right, software developers, they check. They check the HTML, they check the code, etc., or the application that is sending this message, everything. And they're saying, and they said, we are also fine. We are sending the correct message. Hi, how are you? Okay, we are sending the correct message. Now, the problem is that we as network engineers say, it's not my problem. It's, yeah, right. It's not my problem. Similarly, the software engineers at layer 5, 6, and 7, they also say the same thing. It's not my problem. But there is problem that the message is incomplete. Right. So for this purpose, that when the two sides, they say that it's not my problem, but there is a problem, and the two devices need to send the other device a message that the need to send the message or inform the other device that whatever you have shared is incomplete. You need to resend that data to convey this message. Layer 4 was created. Layer 4 was created, wherein when PC number 2 sees that the information that has been sent by PC number 1 is incomplete, it sends back a message saying that, hey, the message is incomplete, right? You need to send this again. Then only I will be able to understand your complete message. So can you send me that message once again or not? Okay, so this work of sending back a kind of notification or kind of information which helps the sender understand that his message is incomplete and that he needs to send or resend it. That is the work of TCP, Transport Control Protocol. Okay, that is why TCP is created. TCP is used for basically acknowledgement. Until and unless there is an acknowledgement, the sender does not know if whatever message he has sent is received completely on the other side or not. TCP is purely used for acknowledgement of your data. There's no other use of TCP. All right. Now, we know that in layer 1, okay, in layer 1, your data is sent in the form of electrical signals, like electrical signals or light signals. Okay. In layer 2, we call your data as frames. Right? In layer 3, we call your data as packets. And then at layer 4, you call your data as segments. Okay, segments, packets, frames, electrical signal or lights. Okay, so what happens basically is that when your data, let's say this is PC number 1 and this is PC number 2. Okay, when your PC number 1 is running some application at layer 7, we know that at layer 7 you have all the applications running. Even whatever you can hear my voice, you can see my screen sharing. Okay, we all are connected over Zoom, which is an application, right? All of it is running at layer number 7 of your PC. That is the application layer. Correct. Now what happens is that whatever information is created by the application layer, it is basically sent down to the layer 4 of the sender side. So whenever we are talking about TCP, there is always one sender and there is always one receiver. Okay. So what happened? The sender application pushes down the data of the application layer to the layer 4. thereby creating segments. Okay, this segment then is encapsulated in layer 3. Layer 3 is encapsulated in layer 2. Layer 2 is encapsulated in layer 1, and then it is sent to the receiver. The receiver decapsulates from layer 1 to layer 2, decapsulate it to layer 3, decapsulates the segment in layer 4. Then the layer 4 TCP, the receiver side layer 4, sends this application or data to layer 7. Okay, this is just a gist of what actually TCP does. So with this, we come to know that on your sender side, there is a TCP program. And on your receiver side also, there is a TCP program. So every networking device which understands layer 4 will have a TCP program running on it, which is at layer 4. So when we are discussing TCP, I will always use these words: sender, receiver, TCP side sending, sender side TCP and receiver side TCP. Okay, and we will be concentrating mostly on the layer 4 segments. Okay, now the PC on the sender side. Okay, the sender over here, and we have a receiver. This is another PC. Okay, both the TCP of sender and the TCP of the receiver have something called as a buffer. They have something called as a buffer. Okay, what is a buffer? Buffer, you can think of it as a storage capacity. Okay, they have something called as a storage capacity, just like your hard disks on your laptop, on your smartphone or your smart TV, etc. They have a storing capacity, which basically we understand it as ROM, right? In our computers or in our phones, we call that as a ROM. So buffer here, TCP also has the TCP program also has some buffer or storage capacity. Okay, so in TCP's terms, we call it as buffer, nothing else. Okay, now you may think of this buffer or you may imagine this buffer in multiple ways or different ways. Okay, either you can imagine it as like in YouTube's or in internet, whenever you're trying to access something, you will see something like circle. You will see circle if you're into Netflix and the data is loading, right? Your screen is loading, you will see something like it's circle. It is circling. Okay, so imagine your buffer as this circle that is going on. Okay, and in some books this buffer is shown as a bucket. This buffer is shown as a bucket. Okay, but since we mostly see buffering in the form of circles in real time, I will draw this as a circle. Okay, can I draw shapes? Can I draw shapes? Can I draw shapes? So consider this as that buffer. Okay, these buffers have different chambers. Okay, just divide them into different chambers. So this buffer is also the same kind of buffer. You may see it on the receiver side as well. You may see it on the receiver side as well. Okay. So the sender side and the receiver side both have buffer. Now, what is the purpose of this buffer? So when your data from your sender application level, the layer 7 application, when it sends down the data, what happens is that the TCP program at layer 4 or the sender side first stores this data in the buffer chambers. It stores it in the buffer chambers like this. Okay. Or you can imagine that as the bucket over here, and this bucket keeps filling up. Okay. So as I said, buffer is nothing but a storage capacity. So your data is being stored in that chambers or in the bucket over here, right? Now, and then what happens from this buffers, from this buffer, a segment is created. Okay, a segment is created. Okay, so we, as I said, in layer 4, we call the data as segments, right? Segments are created. Now, segments is a data of some bytes. It can be 10 bytes, it can be 100 bytes, it can be 1000 bytes, anything, but it is a byte. So let's imagine this segment is a 10 bytes of segment. So we'll segregate this like rectangle into 10 different bytes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So you have 10 buffers. Okay. So this is a segment. Segment is of 10 bytes. So what happens when your buffer is getting full? By as your buffer starts to get full, the data, right, as per the requirement, we'll talk when that requirement comes later. As per the requirement, what happens? This data is pulled out from the buffer, and it is as per the sender's requirement. It is as per the sender's requirement. It creates a segment. So imagine that this sender created 10 bytes of one segment. It created a segment of 10 bytes that you can see over here. Then what happens? This segment, this 10 bytes of segment will be sent to the receiver side. Then what happens? The receiver, upon receiving the segment, will store this segment in these chamber. Okay. Or as I said, the receiver side will also have the buffer. So here buffer. So what happens? This buffer gets stored in the bucket of the buffer of the receiver side. Then when the receiver side application, when the receiver side application needs this data, it will pull it out. It will pull it out towards itself. And that is when you see data on your screen. So currently, imagine what is happening. Me, I'm speaking, I'm sharing my screen. If I switch on my video, you will also see my video. So what is happening? All this data is running on the application side. So all this data, first what happens? It is sent from the application layer of my PC to the TCP layer or the buffer of my PC. It gets all this data, my voice, my video, my screen sharing, everything gets stored in the buffer first. Then what happens? The TCP buffer, it creates segments of my data. So it created a segment, and my voice, my data, my screen sharing is sent to your PCs. Now, what happens? My data, whatever data has been sent, is stored in your PC's buffer. That is in the TCP layer. Then the Zoom application that is running on your system pulls out the data from the buffer and shows it to you. This is how basically your TCP is working. Any question up till here?
Sir, the buffer size, how decided in between
Yeah,
sender and receiver?
we will come to that point later. But till here, any problem of what is actually happening in the buffer? Sorry, what is actually happening in the TCP process? Srinivas, Krishan?
Um, like normally you have taken example like Zoom application. Huh? Now, is this works on TCP? Like normally I'm asking it will work on UDP, right? Like I have some doubt on.
Yes, this works with UDP also. UDP also has buffer system.
Okay, okay,
UDP also has buffer system, but there is a difference. We'll talk about that probably in the end of the whole TCP discussion.
okay, okay, yeah.
Okay. So it's not only over here. Even if you're running the Netflix application, this is what is going to happen. So imagine this as your Netflix application or your Netflix server. So you're watching some movie. So what is happening? The Netflix server is sending the data to its TCP layer, and the Netflix data is getting stored in the buffer over here. And then as the movie progresses, the data is then pulled out of the buffer, made into a segment, sent to your PC. Then your PC stores this data in its own buffer, Then as the movie progresses, the data in the buffer is pulled out to your laptop or your mobile screen. Clear? Any question? Okay. I hope till here everything is okay. All right. So what I told you right now is the basic TCP process of what is actually happening. Okay. So I told you how the data is flowing in very small, brief manner. Now, before this data starts to flow, there is one important factor that happens. So this is the sender and this is the receiver. Now, before the data transfer happens, before all your data gets stored into the buffer, then made into a segment, sent to the receiver, etc., there is one major feature that happens between the sender and receiver, and that is what you call it as three-way handshake. Okay, so again, this is an interview question. Explain the TCP three-way handshake. This is one of the important questions. Explain the three-way handshake. So what happens in a three-way handshake? Again, this is before your data transfer that we just saw. Okay. So three-way handshake. What happens here? So in a three-way handshake, what happens is that when the sender wants to send a data to the receiver, okay. So what the sender does is first, it sends a synchronization message, a SYN message or a synchronization message. Okay. Now, for this synchronization message, the receiver sends back an acknowledgement that, okay, I acknowledge your synchronization message with my acknowledgement. Along with this acknowledgement, the receiver also sends its own SYN message or synchronization message. Okay. Now, the sender received the acknowledgement for its own SYN message because it also received the SYN message from the receiver. It needs to respond with an acknowledgement for this SYN message. Okay. This is basically what is happening in your three-way handshake. The sender sends a SYN message saying that I want to synchronize with you to the receiver. The receiver sends back an acknowledgement. Along with the acknowledgement, it sends its own SYN message as well. For the SYN message received by the receiver, the sender sends back an acknowledgement. And hence, this is called as a three-way handshake. Now, this three-way handshake is also called as, in interview, sometimes they call as, say it as, can you explain the SYN, SYNAC, and ACK process? SYN, SYNAC, ACK process. It's a very simple term to understand and memorize the TCP three-way handshake. SYN, SYNAC, and ACK. Now, before we go further, this three-way handshake, as we know, the sender is sending the SYN message to the receiver. So till now, we learned in layer 2 and layer 3, when a sender is sending some message to a receiver at layer 2, it has a source MAC address, it has a destination MAC address. When the sender is sending a data at layer 3, it has a source IP address and a destination IP address. Similarly, at the layer 4, when a sender is sending a message or a segment towards the receiver, it has a source IP and it also has a destination IP. Not IP, I'm sorry, I'm absolutely sorry, not IP. Source port and destination port. This is not sport. This is not sport. This is source port. Okay. So source port and your destination port. So in TCP, you have many well-known destination ports. Okay. So you can see that there are a lot of destination port numbers. And if you see here, these are the well-known port numbers. So in the internet, whenever we are trying to access some device, it usually has a very well-known port number. Okay, so whenever we are trying to access Netflix or anything on the internet, it usually has a port number of this port number 80, which is for the HTTP. Okay, if you're trying to access, if you're trying to telnet or do an SSH to some other device in the network, if you're trying to gain a remote access, you will use secure shell SSH with a port number of 22, and telnet, you sometimes do telnet with a port number 23, right? So these numbers that you see from 0 up till, you can see it goes up till 1023. These are well-known port numbers that has been pre-programmed on your networking device. So it can be your phone, it can be your laptop, it can be the printer, it can be a server, anything. It has been pre-programmed. The moment you're trying to reach some application, it is completely dependent on the application that you're using. Zoom is an application which can be reached to the Zoom server only through the internet. So your device knows that this is an application which is on the internet. To reach this application, the data first go to the Zoom server through the internet. Because it is going through the internet, my data that is being sent will be sent using a TCP port number of 80. Anyway, there is a difference. Whatever we are seeing right now, or whatever you are hearing right now, is not running on TCP, it is running on UDP. Okay, it is running on UDP. Let me show you that as well. So you see, there is a lot of data that is going on. Okay, first of all, the Zoom application is running. You are seeing my screen, so it's a kind of data. You can hear my voice, it's a kind of data. If I switch on my video, it's a kind of data. So all that data is being sent. You can see the data that is being sent. And you can see every time the data is sent, it is sent at UDP. It's not TCP, it is UDP. Okay. So why UDP? I'll come to that point later. However, just remember whatever live is going on. It can be your YouTube live, it can be your Zoom live session, it can be your live matches, live cricket match, live basketball match, live football match, live Olympics, whatever you watch live on your phone or your TV, even the live news, everything is running on UDP. Okay. But whenever whatever is not live, you're trying to access Netflix. The movies are already on the Netflix server. It's not live. The movies are already on the Netflix server. You're just fetching those movies from the Netflix server to your PC. That is running on TCP because there is an actual data transfer. Right? Then you're trying to access a bank. You're trying to access your bank server. You're trying to check your balance in the bank, in your account. That is not a live data. Your data is already there in the bank's server. You're just pulling that data and seeing it on your screen. That is running on TCP. Okay. So the major difference between TCP and UDP is that, again, we'll come back to the three-way handshake in depth later, but the major difference between TCP and UDP is that, as I said, TCP is used for acknowledgement, whereas UDP does not have acknowledgement. This is the major difference between TCP and UDP. TCP is relying on acknowledgement, whereas UDP does not have acknowledgement. So basically, as I said, all your live application is running on UDP. So just imagine when whatever I say, whatever you hear, whatever data you see from my screen is UDP because it's just unidirectional flow from my PC to the Zoom server, from the Zoom server to your PCs. So if you do not hear my voice, you will see a break. You will see a break in the voice or a break in the videos. And then you will say, Laksh, we cannot hear you, or we cannot see your screen, or we cannot see your video. Again, that is a unidirectional. You are saying it is going to the Zoom server, and then it is being received to my PC. If it was a TCP, if this was a TCP, what would have happened? So let's say if this was running on TCP, so my PC goes to the Zoom server, and from the Zoom server to your PCs. So my voice is being sent through the internet. Zoom is on the internet, right? Let's say there's some break, right? And you do not hear my voice, right? You do not hear my voice. Suddenly, what happens? Let's say my voice, my voice is a data, right? So data number 1, data number 2, data number 3, data number 4, data number 5, like that. It is going through the internet to your PC. Suddenly what happens? Data number 3 breaks and you do not hear my voice. If it was a TCP relying on acknowledgement, your PC would say that to my PC that it did not hear the data number 3. So what is going to happen? You will receive data 1, data 2, data 4, data 5, then you will receive data number 3. So you will hear all gibberish. Okay, so when I send, hi, how are you? In our earlier example, right? How got lost. So your PC is sending to my PC that you need to send the how message again. So now your PC has already received hi. Okay, are you question mark. Now when my PC again sends how, now you will receive it as hi, are you question mark how. So again it's gibberish. It is gibberish. That is why most of your, not most, every live sessions, Zoom is a live session. Whatever Teams meeting you have, whatever Zoom meeting you have, whatever live matches you watch, everything runs on UDP, because if there is acknowledgement during live sessions, your data is going to be scrambled. And again, it will not make any sense. It will not make any sense. Your flow, the flow of the real-time flow will break. That is why most of them are running on UDP, not on TCP. Okay. Now coming back to our three-way handshake. So as I said, your port numbers are well-defined port numbers. So when the sender is sending this three-way handshake to the receiver, it will use a well-known destination port number. And as I said, it is completely dependent on the application that you're using. Okay, the application that you're using. So let's say that you're trying to you're trying to view Netflix. You're trying to view Netflix. Netflix is on the internet. What is going to happen? The sender is going to send this three-way handshake to a destination port number of 80, which is on the internet. Okay, which is on the internet. And the source port number is going to be a random port number that is generated by my PC. So the source port number that you can see here is 50. Okay, 55028. Okay, so let's check what is 55028. Fifty-five.
Double 50, no? 5 numbers. It will be at 10.
55028.
Wait.
Yeah. Right. So here, these are dynamic, private, or ephemeral ports. Dynamic, right? Private or ephemeral ports. What is ephemeral? Meaning that it is on, it's a random port number, and it may go, it just used by any device. Okay, it will be used by any device, and it will be you, and that port number will vanish. Okay, so you can see here from 49,000 up till 6161 or even 65535. Okay, these are all your port numbers that are used by your devices, source port numbers that are chosen at random. Okay, so once my Zoom application is over, what is going to happen? My PC will forget that port number, the source port number that you see here. The source port number of 55028 that you see here, my PC will forget that port number completely. Okay, The next time when I'm trying to connect with Zoom number, probably you will see some other port number. So as I said, this port number, the source port number by the sender is chosen at random. This port number, source port number, is chosen at random. Okay. So the first thing that the sender does is it will send a SYN message. For this SYN message, the receiver will send an acknowledgement along with its SYN message. Now with this SYN message, for this SYN message, the sender needs to respond with an acknowledgement. And this is how a three-way handshake happens. Once a three-way handshake happens, that means the TCP connectivity between the sender and the receiver is established. Once it is established, now the sender can send data over the TCP connection to the receiver, or the receiver can send data to the sender over that TCP connection. And that connection is called as a socket. The connectivity that happens after the three-way handshake is called as a socket. You can imagine socket as an invisible tunnel between the sender and the receiver. Through this socket, the sender will send data to the receiver and vice versa. So a socket, a TCP socket, is created at destination port number with the sender at a random port number. Clear? Any question up till here?
Um, so basically, why we need like three-way handshake to whether to receiver is alive or not to check for that purpose? Like if anyone asks about that, why we need three-way handshake?
Okay. So to compare it with OSPF, OSPF sends a hello message, right?
Yes.
Why does it send a hello message? It sends a hello message to introduce itself that, I want to start forming a neighborship or adjacency with you. Once the neighborship is formed, it will start sending the database. Similarly, over here, the sender first wants to shake hands. Similar, OSPF is also, the OSPF hello message is basically like a shake hand. Hi, I am this router. My router ID is this. My hello timer is this, right? And the other router will also send his own hello message. When the two hello message are negotiated, then they move to exchange their TPD. This is what is happening over here. The sender is sending a hello message, which is basically the SYN message. For this SYN message, it is acknowledging. So basically like hello. Okay. This is also sending a hello. So let's say that okay, yeah. So let's say whenever you guys join the Zoom session, right? Whenever you guys join the Zoom session, you say hi sir or hi Laksh, right? So that means you are sending a hi to me, and I will respond hi Vivek, hi Srinivas. So what is happening? My hi is actually a hi as well as an acknowledgement that I have heard your hi. Correct? You said hi. You said hi to me, right? I respond with my own hi, which is basically also an acknowledgement that I heard your hi. That is what is happening over here. So the sender is sending a SYN message. The receiver is sending its own SYN message, which is also acting as an acknowledgement. Now, why the third acknowledgement? It is just like more of what do you say, humble response. I heard your acknowledgement. I heard your hi. I'm again acknowledging your hi. So sometimes happens between friends. Like, hi Srinivas, hi Laksh, hey, hi Srinivas, can you? So sometimes we say hi 3 times. And this is what exactly is happening in the three-way handshake. So the three-way handshake is like we are making friendship. First, the two the sender and the receiver, they're introducing each other, right? And then they will start to talk to each other. When they're talking, they are basically sharing information. So you say, hi, Laksh. I say, hi, Srinivas. So Laksh, again, so you called my name two times. And then you start saying questions. So Laksh, I heard this question in an interview. That's a data sharing. That is what is happening in three-way handshake. Clear?
Yes, yes.
Okay.
I have another question. Like before this TCP three-way handshake completed now, so until unless it is established, they cannot transfer the data, right? So
Correct.
whatever data coming from the upper layers, all the data will be stored in that buffer only until still connection happen in between sender and receiver. How much data it will store that in the buffer, like because
Okay.
it
So
is
that's
continuous streams
yeah,
of byte, right?
that is what. So as I said, every application creates its own buffers. Not creates its own buffer. TCP buffer is a huge buffer. Okay. So as you, it depends on the number of applications that you're running on your device. I'm running Chrome. Let's say I'm running Netflix. I'm running YouTube. I'm running Facebook. So these three, Chrome is an application. Netflix is an application. Facebook is an application. Okay. So I'm running three different applications on my device. So what will happen is the TCP program will create three different buffers for those applications separately. Got it? So as I said, it depends on the number of applications that you have in your system. So the more applications you're running, the more buffers will be created. Okay. And again, if you remember why nowadays we think on RAM, the higher RAM, the faster your PC will work, right? Basically, your RAM and your TCP program are interconnected. The higher RAM, it will be easier for your TCP process to make different buffers for different applications and work on those TCP buffers simultaneously. So for a less RAM of device, okay, let's say there is a PC with just, let's say, 8 GB RAM. Okay, I'm not sure how many buffers it can create in the TCP, but let's hypothetically imagine it can create 100 buffers simultaneously for 100 applications. Example, okay, hypothetical example. But whereas a 32 GB RAM can create, let's say, 1,000 buffers, okay, for 1,000 applications. So what is happening? This means that the 32 GB RAM can handle 1,000 buffers simultaneously. 8 GB RAM can handle only 100 buffers simultaneously. So if you run more than 100 application, let's say you start to run 120 applications, so it need to create 120 buffers. But the limitation of this 8 GB RAM is it can perfectly run with 100 buffers. But the more you go beyond this buffer, it slows down. So what happens? Your TCP application or the TCP buffers will be hindered. The processing will get slow. It is true for 32 GB RAM also. If you go beyond 1,000, let's say you are running 2,000 applications, or it needs 2,000 GB of 2,000 buffers, then that's difficult for even the 32 GB RAM as well. Clear?
Yes, yes.
Okay, with this, I'll stop today's class. because to be very honest, I need to revise the TCP again uh, to go with the flow, to make you guys understand the flow of TCP one by one. Right.
Yes, yes. Okay, no problem. But yeah, it is very important topic. Now you can take more time, no problem. So, but
No, no, no. I can take today, but the thing is, it has been a long time that I took TCP. So like the flow of the TCP, like in TCP I should take this topic first, then this topic second, third, fourth. That flow I cannot recollect today.
oh, yeah, okay, okay. Yeah, yes, yes, no problem. Yeah, yeah,
Yeah, yeah. So I'll continue this on Monday.
sure. Uh, please take more sessions if possible on this TCP actually. If
Yeah,
possible,
yeah. I'll
you can
yes, yes.
reduce
Sure, sure.
that MPLS little bit portal, no problem, but take more on this TCP port.
Yeah, yeah. Sure. Don't worry.